a low power PAN has been implemented using different link layer technologies, a mesh over routing setup is useful. While traditional IP routing protocols can be used, a specialized routing protocols for smart objects such as RPL is required. What is RPL? RPL is nothing but routing over low power and lossy network. Here we are optimizing IP for an IOT RPL. IETF charted the role, that is routing over low power and lossy network. Is the work group it is going to be to evaluate all layer 3 IP routing protocols and determine the needs for requirements for developing a routing solution for an IP smart objects. Basically this is used for IoT networks. The new routing protocol should be developed for use by IP smart objects is IPv6. In short, they are calling it as routing protocol for low power and lossy networks, RPL. In RPL network, each node, how it works basically, what are things it is going to be there in that. Each node acts as a router and becomes part of a mesh network. And routing is performed at the IP layer. Third one is each node examines every received IPv6 packet and determines the next hop destination based on the information contained in the IPv6 header. The constraints of computing the memory that are common characteristics of constrained nodes and protocol defines in two modes. First is sorting mode, another is non-sorting mode. In sorting mode, all nodes contain the full routing table of the RPL domain. Every node knows how to directly reach every other node. In the sorting mode, very simple it is. All nodes contains full routing table, so it is going to have from the source to the destination. In between, whatever the hops are going to be there, all the things that it is knows, then directly it can reach to the every other nodes. In case of non-routing, non-storing mode, we have only the border routers of the RPL domain contain the full routing table. All other nodes in the domain only maintain their list of parents and use this as a list of default routers towards the border router. This abbreviated routing table saves memory space and CPU. When communicating in non-storing mode, a node always forwards its packets to the border router, which knows how ultimately reach the final destination. See that here, how that basically works, what is node and how it is. So example has been taken for the one of the example where the source and destination are going to be there. Usually it works with the DAG, that is directed acyclic graph. RPL is based on the concept of directed acyclic graph DAG. Is a directed graph. You can see that here all the directions are going to be there. These are all the nodes which is going to have. Then the data is getting forwarded from source to the destination. A DAG is a directed graph where no cycles exist. You can see here there is no cycle. seems to be here cycle, but there is no cycle. It is because you see that here when it goes from 7 to 11, 11 to 9, but there is no connection between 11 to 8. Similarly, when it goes from 7 to 11, 11 to 10, you don't have 10 to 3. There is a connection is not exists, but 3 to 10 exists here. Okay, so here if you see that all are independent nodes and directly it is getting connected. Okay, but there is no cycle. Suppose here 9 to 8 if it was, then there is a 7, 11, 9, 8. So there is a circle is there. So here there is no circle. That is called as acyclic graph. This means that from any vertex or point in the graph, you cannot follow the edge or a line back to this same point. So all of the edges are arranged in paths oriented towards the terminating at one or more root nodes. Now you see that here. There is a 2 is there, 9 is there, 10 is there. Here if you consider 8 is there. So different terminating points are existing here. Okay. A basic RPL process involves building a distinction oriented directed acyclic graph, that is destination oriented directed acyclic graph, DODAG. Now you see the same thing in the diagram that it is displaying. A DAG, suppose is a DAG, second is DODAG. DAG is nothing but a directed acyclic graph. DODAG is destination oriented acyclic graph. What is the difference then? In the DAG we are having more than one destinations. Now you see from here to here, from here to here there is one destination, second destination, from here to here if you say third destination. Source also it is going to be different. Maybe, but destination should be in the DAG it is more. But in case of destination oriented directed acyclic graph, here it is n number of inputs are there, that is nothing but sources are there, but reaching the node, that is destination node, is only one. See here, DAG is one is there here, from here it goes here and here. So destination is one. In case of DAG, destinations are more. In case of DODAG, only one. A DODAG is a DAG routed to one destination. In RPL, this destination occurs at a border router known as the dog route, DODAG. Okay. Destination occurs at destination oriented directed acyclic graph route. Observe that the DAG has multiple routes, whereas this is just one. It is not. In DODAG, each node maintains up to 3 parents that provide a path to the route. So here one of these parents is the preferred parent, which means it is preferred next hop for upward routes towards the route. The routing graph created by the set of DODAG parents